Hello everybody, it's Professor Parth, and today we're going to be talking about balancing chemical equations. So, balancing chemical equations are rather simple, but they seem complicated at first. And so, let's have a very simple equation. H2O. So, hydrogen plus oxygen yields hydrogen H2O or water. So, this is not written properly. First off, H and O are diatomic molecules. They should have 2's underneath them. I'll get into that in a bit. But first, let's just balance this. We balance hydrogen first, then oxygen. Or in a normal equation, hydrogen is second to last, oxygen last. And that would just be for simplicity's sake. There really isn't a law why. But okay, so let's start. So we have one hydrogen here. And we have two hydrogens here. And this is how I learned to balance equations when I went through elementary school. So our oxygens are balanced, but we don't worry about the oxygens just yet. Hydrogen here is 1. We want to make it 2. Let's do that. 2H plus O yields H2O. Yeah, that's right. And this is right, and this is right. And that's how you balance chemical equations in its most simplest form. But this chemical equation is actually wrong. Because first we need to learn about something called diatomic molecules. So, a good way to remember diatomic molecules is Brinkelhoff. Brinkelhoff. And this stands for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So what this means is that bromine, for example, will always be Br2 or I2 or N2 or H2 or O2. And so let's revisit this equation right here. So instead of having 2H plus O, this is what we would have. H2 plus O2 yields H2O. This is not balanced yet. This is what most people think is balancing equations. This is wrong. This is incorrect. This is how you would balance an equation. So H2 plus O2 yields H2O. Now we need a balance. H equals 2, H equals 2. O equals 2, O equals 1. Hydrogens have been balanced. That's good. Now time to move on to oxygens. So the best way here to do this would be just to add a 2 here. Now we have 2 oxygens, but now we have 4 hydrogens. And here we have 2 hydrogens. So what we do here is we have 2H2. That makes 4, 4, 4, 2, 2. And that makes this equation balanced. Now let's try some more harder problems. These are like the most simplest chemical equations that you'll have to balance in middle school and possibly high school. Now let's go into something a little more complicated. Let's do this. Cl4I. These I's aren't really anything that you need to worry about. They just say if they're aqueous, a solid, or a liquid. Actually, my apologies, this is an L. This means that this is a liquid. Plus, leave a space here for any coefficients right here. H2O L. Yields. This arrow means yields. SiO2, and this is a solid, plus HCl, which is hydrochloric acid, and this is actually AQ. And what AQ means is that it's aqueous in water, or it's an aqueous solution. So let's get to work. Remember our rule, hydrogen and oxygen last, hydrogen second to last, oxygen last. So let's get started. Si Cl, and hydrogen and oxygen. So Si plus Cl plus hydrogen plus oxygen. Here it equals 1. Cl equals 4, oxygen equals 1, and hydrogen equals 2. Over here we have this equal 1, oxygen equal 2, hydrogen equal 1, and Cl equal 1 as well. So silicon, silicon, balanced, balanced, Cl4, Cl1. So what we do here is we put a 4 here. That amazingly turns this into 4. But now our hydrogen is also 4. So now chlorines are balanced. Hydrogen 2, hydrogen 4, put a 2 here. This becomes 4. Oxygen now becomes a 2. Oxygens have been balanced already for us. Hydrogens are done. And this equation has now been solved. Very simple, very easy. And I'll come out with another video to explain more complex equations, but this is just basically fundamentals, i.e. day 1, day 2, and day 3 of learning how to balance chemical equations. And this is actually high school chemistry. So, let's go on to let's do one more equation before we end out today. Let's have one using gold. This will be Au2 aurum or gold S3 plus, leave a space, H2 yields Au or aurum or gold plus H2S. And this is actually a special kind of chemical reaction. This is called single displacement or single replacement reaction, where the two nonmetals swap out with each other. So, let's start. I should probably rewrite this again. So, Au equals 2, S equals 3, H equals 2, Au equals 1, H hydrogen equals 2, and S equals 1. And these two should be reversed. Always have it so that they're always in order. But I can work with this. So Au2, Au1. Put a 2 here. This becomes a 2. This is balanced. This is balanced. S3. We have 3 here. Best way to do that is to put a 3 coefficient right here. This becomes a 3. Silicon and silicon are balanced. But now our hydrogen here is a 6, not a 2. Our hydrogen here is a 2. Put a 3 here, becomes a 6, 6, 6, and we're good. And that's all there is to it. So until next time, Professor Parth out.